The surviving Shepherd master clock at Greenwich is evidence that by 1852, public clocks were already part of a wired time network. Its signals traveled through telegraph lines to London, Edinburgh, Glasgow, Dublin, and Belfast. By 1866, they were crossing the Atlantic to Harvard University. A clock face in a city square was no longer keeping time for one building. It could be displaying an hour transmitted from somewhere else. Railways and industrial schedules needed synchronized time, but accuracy did not require a stone tower looming over a station, university, or parliament. So why did cities turn an invisible electrical signal into one of the largest and most authoritative objects in the street? At the Royal Observatory in Greenwich, the mechanism at the center of that question still survives. Royal Museums Greenwich identifies it as Object RMG C79636, the Shepherd electrical motor clock, installed in 1852. It was not simply an accurate clock in an important building. It was the central mechanism of a system. The motor clock sent electrical impulses to connected, sympathetic clocks, remote dials that depended on the master for their time. One stood at the observatory gate. Anyone approaching Greenwich could look up and see the hour, yet the visible face was not working alone. Its hands responded to signals from the mechanism inside. The gate dial became the first public clock to display Greenwich Mean Time directly. The object looks familiar now. A face, two hands, a public entrance, but behind it was a new separation. The place where time was calculated no longer had to be the place where time was seen. The mechanism could remain inside the observatory while its authority moved outward through wires. From 1852 until 1893, the Shepherd clock served as the heart of Britain's time distribution system. Signals reached major cities, railway facilities, and hundreds of local receivers. A connected clock was installed at the London Bridge terminus of the Southeastern Railway, and Greenwich signals traveled along principal railway lines. Time was becoming a network. Before standardization, towns commonly kept local solar time. Noon arrived when the sun reached its local position, so a town farther east or west could live by a slightly different clock without either place being wrong. Royal Museums. Greenwich notes that the difference across Britain could amount to roughly half an hour. For centuries, that variation had been ordinary. A town clock could agree with its own noon, even when it disagreed with a clock farther along the road. The difference was local, predictable, and usually harmless. Then, railways turned it into a problem. A timetable could not function safely if every station interpreted the hour according to its own sky. A printed departure in one town had to correspond to an arrival in another. Connections, signaling, and track movements required agreement across distance. The practical need for common time was real, and telegraphy supplied an efficient answer. The old landscape of many local noons was being reorganized around one transferable standard. Yet the new system created a contradiction. Once one master clock could control remote dials, a public display could have been modest. It could sit above a station entrance, on a municipal wall, or beneath a simple canopy. The electrical pulse did not require a tower. Precision did not require carved stone. Synchronization did not require a monument on the skyline. But cities repeatedly chose height. They raised clocks above railway terminals, universities, government buildings, parliaments, and central squares. They surrounded the dial with masonry, arches, roofs, bells, and ornament. The clock became not only an instrument, but a presence. In 1866, the distance between source and display grew larger still. Through the new transatlantic cable, time signals from the Shepherd clock reached Harvard University in Cambridge, Massachusetts. Electrical time distribution had crossed the Atlantic decades before radio broadcasting and digital clocks. The signal itself was almost weightless. It moved unseen through a cable. The architecture built around public time became heavier, taller, and more permanent. That is where the pattern begins. The accepted explanation begins centuries before Greenwich, railway timetables or telegraph wires. Cities had long built towers for bells, alarms, and public announcements. UNESCO's group of 56 belfries in Belgium and northern France includes structures erected between the 11th and 17th centuries. Their bells marked hours, warned of danger, and called communities to civic duties. Height carried sound beyond roofs and market streets. Visibility made the tower a recognizable center of urban life. These were also political structures. UNESCO describes the belfries as symbols of municipal independence and of the transition from feudal authority toward self-governing urban society. The tower was not merely a support for a bell. It could embody a town's charters, institutions, and collective identity. Its bells announced more than hours. They could summon citizens, warn of attack or fire, and mark the authority of the municipality itself. That older meaning never disappeared. Long before electrical synchronization, height had already taught urban populations to associate public time with the institution that controlled the bell. 19th century clock towers, therefore, did not appear without ancestors. They grew from belfries, churches, town halls, and mechanical public clocks that had occupied skylines for generations. Bells had always done more than tell time. They organized worship, labor, markets, ceremonies, and emergencies. The 19th century changed the scale. Railways connected places that had previously followed local rhythms. Telegraph systems moved information faster than any person or train. Factories, schools, shipping firms, government offices, and expanding commercial districts needed time that was increasingly precise, shared, and visible. A high dial could be seen across crowded streets. A bell could reach people beyond the square. A tower could rise above smoke, traffic, and new construction. Municipalities also had reasons to build monumentally: civic pride, competition, commemoration, and the desire to associate public institutions with order and progress. The clock tower solved several problems at once. It told time. It marked a place. It projected identity. It turned a technical instrument into public architecture. The Palace of Westminster offers one of the clearest examples. The great clock inside London's Elizabeth Tower began keeping time on May 31st, 1859. Its design joined monumental political architecture to an unusually strict mechanical demand. The clock was expected to remain accurate to within 1 second when striking the hour. Telegraph signals from the Royal Observatory were used to test that accuracy. Greenwich's electrical system and Westminster's enormous mechanical clock were not separate worlds. The invisible signal could judge the monumental machine. 5 bells made the result audible. 4 quarter bells sounded every 15 minutes. The 13.5-ton Great Bell struck the hour. A person did not need to stand beneath the tower and study the hands. London could hear the day divided into measured sections. Nothing here requires a hidden civilization or a secret construction program. The tower has a documented date, purpose, setting, and engineering history. Nor were all clock towers connected to Greenwich. Some grew from civic traditions, some belonged to railways, some served government buildings, universities, or memorial projects. The record explains why clocks needed to be visible, why bells needed height, and why institutions wanted impressive architecture. But it does not settle the proportion. How much tower was required to tell the hour? How much stone was needed to carry a bell? And how much of the monument was built to make a new system of time feel permanent, public, and beyond dispute? The first crack is not a missing archive record. It is the physical relationship between the shepherd system and the towers that followed. At Greenwich in 1852, the essential technical idea was already working. One master clock could send impulses to multiple dependent dials. The public did not need access to the mechanism that generated the signal. They needed only a visible face responding to it. Time had separated into two layers. There was the source, the mechanism and institution from which the signal originated. Then there was the display, the clock encountered by the public. Once those layers were separated, the display could take almost any form. It could be small or monumental, plain or ornate, mounted on a wall or lifted over a city. The electrical pulse did not care whether it moved the hands of an unadorned station clock or a dial framed by towers and bells. That choice belonged to people. 7 years after the Shepherd system was installed, the great clock at Westminster began operating. At Greenwich, impulses moved outward through wires toward railway facilities and remote clocks. At Westminster, a vast mechanism occupied a tower attached to Parliament. Telegraph signals could test its accuracy, but the public did not experience a test signal. They saw a facade above the river. They heard 4 quarter bells divide the hour. Then they heard a 13.5-ton bell announce it. A clock fixed to an ordinary wall offers information. A clock raised over Parliament offers information from above. That difference does not prove a secret intention. Monumental buildings have always used height for visibility, ceremony, and prestige. Yet the visual language remains difficult to ignore. The standard was measured at an observatory, transmitted through a technical network, and encountered through institutions that dominated the street. The transition did not happen in one night. Local time did not vanish at a single command. But in 1880, the Statutes, Definition of Time Act established that references to time in British statutes, legal instruments, and deeds would mean Greenwich Mean Time, unless another meaning was specified. The Act did not force every private clock to adopt Greenwich Mean Time. It did something more precise. It gave Greenwich time an official legal position. The change was therefore not only mechanical, it was administrative. A standard produced from one location entered railway schedules, public signals, legal language, and daily expectation. The nation was learning to share an hour. One reasonable interpretation is that monumental clocks helped make this abstraction feel natural. A telegraph pulse could not be watched crossing a city. A legal definition had no visible body. Standard time was real, but almost invisible. The tower gave it one. Stone made the signal appear permanent. Bells made the standard audible. Height placed the same repeated message above streets, stations, and institutions. The Shepherd Gate clock proves that a public dial could be the visible end of an invisible system. The face could be here. The source could be elsewhere. Once that principle existed, cities faced an architectural choice. They could treat synchronized time as a utility, or they could treat it as a monument. Again and again, they did both. And when the form left Britain, it did not remain attached to one mechanism, one government, or one architectural tradition. In Bombay, later Mumbai, the Rajabai clock tower rose above the public buildings around the Oval Maidan. Its foundation stone was laid on March 1st, 1869. Construction was completed in November 1878. Designed by George Gilbert Scott and modeled partly on London's monumental clock tower, it reached approximately 85 meters, or 280 feet. The tower was not a dial placed where university students could conveniently see it. It became the visual summit of an entire public building ensemble. Time was joined to education, civic prestige, and the ordered image of a colonial city. The official explanation is persuasive. Bombay was a major commercial center. Public time mattered. A university could reasonably display technological confidence and architectural ambition. Scott's design connected the institution to an architectural language already associated with London, but the model traveled more easily than the signal. There is no evidence that Rajabai was controlled by the Shepherd clock, and no basis for claiming that Greenwich secretly operated towers around the world. The pattern does not require a single mechanism. Different cities could build different clocks for different reasons and still produce a similar public image. An institution below, a clock above, a district organized beneath its face. The pattern also appeared beyond the British imperial setting. Academic research identifies 24 clock towers constructed outside Istanbul, within the borders of modern Turkey, between 1876 and 1909. They belonged to the era of late Ottoman modernization and were associated with state policy, local elites, public institutions, and changing concepts of regulated time. They were not identical structures, and they did not rise in one coordinated event. Their patrons, styles, and local meanings differed, yet they addressed the same visible problem: how to place regulated public time into the daily life of a city. The Konak Clock Tower in Izmir provides the clearest surviving image. Built in 1901 for the 25th anniversary of Sultan Abdulhamid II's accession, it stood in Konak Square near the 19th century government house. In one view, a central square, an imperial commemoration, a government institution, and a public clock were brought together. A person crossing the square did not need to understand telegraphy, mechanical engineering, or administrative reform. The arrangement communicated without explanation. The institution was there. The clock was there. The regulated hour occupied the center. This does not prove that Ottoman clock towers were instruments of psychological control. They also expressed commemoration, modernization, civic improvement, and local ambition. Architecture can perform several functions at once. A tower can be useful and symbolic. A clock can coordinate activity and represent authority. A monument can celebrate an accession while placing standardized time into the daily path of the public. Across the wider pattern, the political meanings changed. Medieval belfries could represent municipal independence. Westminster joined parliamentary power to mechanical precision. Rajabai linked a university district to imperial architectural prestige. Konak connected regulated time to government space and commemoration. Yet the clock repeatedly attached itself to institutions that claimed the right to organize public life: law, education, administration, transport, and commerce. The tower did not create those systems. It made their rhythm visible. Then, at a railway terminus in Hong Kong, the relationship between function and symbol became impossible to miss. The former Kowloon Canton Railway Clock Tower was erected in 1915 as part of the Tsim Sha Tsui terminus in Hong Kong. It stands 44 meters high, with a 7-meter lightning rod above it. Yet its clocks and 1-ton bell did not begin operating when the tower was completed. Delays involving unavailable fittings and instructions kept the mechanism silent until March 1921. For years, the architectural shell stood before its intended timekeeping system fully worked. Passengers could see the tower as part of the terminus, yet the clocks and bell that were supposed to justify it remained delayed. The sequence matters. The tower and the clock were not the same object. One was a mechanism for displaying time. The other was a landmark built to hold it. There is nothing mysterious about construction delays. Specialized equipment often arrives after masonry, but the delay reveals the independence of the monument from the function used to justify it. The tower could dominate the station before it could reliably tell passengers the hour. A railway terminus needed accurate public time. Travelers needed a visible reference. Workers needed a shared schedule. In a station, minutes were not abstract. They determined whether a passenger boarded a train or watched it leave. The practical explanation is complete, but the tower did more than assist movement. It marked the terminus in the skyline. It announced the railway from a distance. It gave the institution a vertical symbol that remained recognizable as the surrounding city changed. Then the station disappeared. After the terminus moved, the station building was demolished in 1978. The tower was deliberately retained. In 1990, it was declared a monument. The functional complex was removed, but the vertical symbol survived. The contradiction can still be seen in the empty space around it. The halls that processed passengers are gone. The station structure that once explained the tower no longer stands. The clock remains, detached from the building that made its practical purpose obvious. A railway clock is supposedly justified by the railway station. Yet, when the station was demolished, the tower became important enough to preserve. Its operational role diminished, but its symbolic value increased. Preservation reversed the original hierarchy. The station had once been the essential machine, and the tower its visible marker. After 1978, the marker became the object worth saving. This is the strongest physical evidence in the story, not evidence of a secret origin, but of a transformation. The tower had begun as part of a transport system. It survived as civic memory. That memory contained more than a timetable. The railway marked the moment when hours and minutes became conditions of movement. Trains linked personal behavior to schedules produced by systems larger than the neighborhood. A traveler had to arrive when the institution said the train would leave. Medieval bells had also organized labor, worship, markets, and emergencies. The older world was not free from discipline, but the scale changed with telegraphy and railways. A distant source could coordinate places that did not share the same sun, street, or local bell. The ordinary clock face became the endpoint of a chain that might include astronomy, electrical impulses, railway administration, government decisions, and international cables. Most people never saw that chain. They saw hands moving, they heard bells, they adjusted their behavior. The tower translated an invisible system into a physical experience repeated every day. It did not need to explain where the hour came from. It only needed to remain visible. Rajabai above the Oval Maidan, Konak in the square near Government House, Elizabeth Tower beside Parliament, the Kowloon Canton Railway Tower above a terminus that no longer exists. Different institutions, different governments, different histories, the same human gesture. Look up. And in Hong Kong, the building vanished, while the command to look up remained. The evidence does not support an unknown civilization, a concealed global construction event, or a secret network of towers. The dates alone show a long, documented sequence. The Belgian and northern French belfries span centuries. The Shepherd system was installed in 1852. Westminster's Great Clock began operating in 1859. Rajabai rose between 1869 and 1878. Konak was built in 1901. The Hong Kong Railway Tower followed in 1915, with its clocks operating from 1921. These structures had architects, patrons, institutions, and local purposes. Their mechanisms and political meanings differed. Some grew from medieval civic traditions. Others belonged to parliaments, universities, governments, or railways. The valid question is narrower and more unsettling. When synchronized time became easier to distribute, why did its public form so often become more monumental? The Shepherd clock demonstrated that precision could be centralized and delegated. A master mechanism could send impulses to remote dials. The difficult task was no longer making every public clock an independent source of truth. So why surround the receiving face with such authority? One restrained interpretation is that the towers helped societies accept a transfer. Time moved away from the local sun and toward institutions capable of measuring, transmitting, defining, and enforcing a standard. The tower made that transfer feel civic rather than technical. At Westminster, accuracy was joined to Parliament and broadcast through bells. At Bombay, the clock rose above a university district. At Izmir, it stood near Government House in a central square. In Hong Kong, it marked a terminus where schedules governed movement. No hidden meeting was required. Cities openly built monuments for beauty, pride, visibility, prestige, and commemoration. Architects and patrons could pursue several aims at once. A tower might improve visibility, honor an anniversary, compete with another city, and strengthen the presence of an institution. But practical and psychological effects can overlap without conspiracy. A bell heard every 15 minutes divides the day. A station clock defines lateness. A clock beside government offices turns an administrative standard into part of the landscape. A tower seen from several streets repeats the same lesson. The official hour is everywhere. Visibility audibility, and authority reinforced one another. The clock was useful because people followed it. The tower was powerful because people saw it. The institution appeared orderly because thousands adjusted themselves to the same standard. Perhaps the deepest power of these structures was not that they forced people to look up. It was that, after a generation, nobody needed to ask why the clock was above them. Return to Greenwich. Inside the Royal Museum's Greenwich collection, the Shepherd electrical motor clock survives as a mechanism from 1852. At the observatory entrance, the gate dial remains visible. The master once sent impulses to sympathetic clocks, railway facilities, and distant cities. It proves something quieter than a hidden network of towers. By the middle of the 19th century, public time no longer had to originate where it appeared. The face could be here. The source could be elsewhere. The signal could pass unseen between them. From that moment, monumental public clocks contained a contrast. The information they displayed could travel with increasing efficiency, but the architecture presenting it remained heavy, expensive, and impossible to ignore. The wire disappeared into infrastructure. The tower entered memory. That is what happened in Hong Kong. The station disappeared, but the 44-meter tower remained. The practical complex was removed. The vertical symbol survived. What had once served a railway became evidence of how deeply the railway's time had entered the identity of the city. The other towers reveal different versions of the same transition. A medieval belfry could represent municipal independence. Westminster could join national politics to mechanical precision. Rajabai could connect education and colonial prestige. Konark could combine public time, government space, and imperial commemoration. They are not identical clues to one lost event. They are a sequence showing how societies gave visible form to the authority that organized the day. Once, towns across Britain could follow different local noons. Railways made that variation dangerous. Telegraphs offered a solution. Law gave Greenwich time and official position. Public clocks turned the standard into daily expectation, and architecture placed that expectation above the street. The signal itself was almost weightless. The tower gave it one. After enough years, the people beneath these clocks no longer felt they were receiving time from an observatory, a railway administration, or a legal standard. They simply called it the time. The signals are faster now. The clocks are smaller. The network has become almost impossible to see. Yet the old towers remain, standing above transformed governments, erased stations and streets that no longer depend on their bells. They continue to display the hour. But behind the hour is the question Greenwich made visible in 1852. When time can be sent from anywhere, who decides where the city must look to receive it?